Hello everyone, welcome to my channel. In this video we'll learn about the importance of time complexity and space complexity. Also this time complexity and space complexity is an important question in any DS algo problem. Uh, Generally our optimization of any algorithm uh, is measured by two factors. One is time complexity and second is space complexity. So let's take an example. You want to purchase a computer. In that case, you'll find that generally the computer price range changes, the difference in price range of due to two factors. One is processor and also hard disk, or we can storage. If you purchase a system or a laptop which has i3 processor, Intel i3 processor, and another has i7 processor, and all other configuration are same, then you will find that generally the i7 processor price is more than i3 processor. Similarly, let's say processor is same, but one gives in one laptop, you will find that let's say 500 GB is the storage, another is in another, let's say it's 750 GB is the storage, then the price also is more for this laptop which has more storage. Then what is this i3 processor and i7 processor, or what is the storage, why the price increase for that? Okay, so here one thing, this processor, it's related to time complexity, and this storage is related to space complexity. That means we will say that for the same task to be executed in i3 processor, it will take more time than i7 processor. When we are saying that it will take more time or less time, here one important factor came, time complexity. And when we are saying that we can store more files if we have more storage, that is related to space or relevant to space complexity. Okay, so time complexity helps us to optimize our task or algorithm to be so that we can execute the task faster, and space complexity also helps us to perform more tasks within same or overall same space of the system. And another thing also we can ask, we can say that okay, if some of the tasks is taking more time in i3 processor, then instead of that I will go for i7 processor. Yeah, we can go for i7 processor, but if you can go for i7 processor, also execute the same task, and alternative approach, if you means if you can get the same thing to be done at the same amount of time in i3 processor by optimizing your task. So that's why algorithm is that we can say that set of task or set of instructions against which all these calculations happens. And when we are saying that our algorithm is optimized, that means optimization in the sense how long it takes to execute, and the time, what is the space it takes. And another important factor here while calculating or while saying that the time completion and space complexity, here we are not considering about the hardware configuration of any machine. So we are just we can say that it's an unit. We consider about the unit. Time is a unit and space as a unit. So this whatever we learned, this processor, those things, those are hardware thing or hardware configuration. So we are not worry or we don't bother about those things. So we'll say that to evaluate any algorithm, we'll consider against time as a unit and space as a unit. So only these two things we will say: time as a unit, space as a unit, and forget about this GB or TB or this processor, those things. In this way, we are evaluating any algorithm or any set of tasks and telling them whether they are more performant or not. So there are some symbols or some we can say measurement for this time and space complexity, and one is, we can say, omega annotation. Omega tells the best case scenario. Always it considers about the best case. Then theta tells average case. Then big O annotation, it tells a worst case. Let's say we'll say that I have written a task inside a for loop. Let's say we are saying inside a for loop I'll search for an element. The best case can be the element, or there is more probable, let's say the element can be found out at the first place. So this is the best case. Best case scenario that means when we are saying that it can be found out at a first place, that means with one loop will execute, or that is order of 1. So that is omega annotation, omega of n, and where n is known as n is a variable. So this omega tells that the at best case I can get it with constant time, or we can say order of 1 also I can get it. That is the omega annotation. And theta tells average case. So on an average how long it takes. And big O, as it always consider about the worst case scenario, in our DS algo problem, always the measurement, whatever the measurement we do, those things is based on big O annotation. Means we will say that how we can say that our algorithm is more performant or algorithm is better, by considering the worst case scenario, or worst case considers the edge cases as well, where the input can be more, means we can say it takes care of all the means big in valid inputs, and check the algorithm, and if it works there, then obviously it will work for other cases. So that's why this worst case scenario or the big annotation is most, or it is widely used in our DSL-Go. Whenever any questions come for DSL-Go and they ask about the what is the time complexity and space complexity, so always consider they are asking this regarding this big O annotation, and we consider or we measure any any algorithm by this big O annotation, and the two factors is there: time complexity and space complexity. and always we take care of variables.
Okay.
Thank you.